Which one, sorry? 90, 2393. Oh yeah, I like it. Page 123, number 93 in section 2.3. Then it tells you, now, it tells you in the problem, refer to example 12, right? So if you look at example 12, it gives you the formula you need to use. Blah, 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 blah. Yeah, well, they kind of tell you exactly what to do. It's funny. So a student takes out 2 loans. One loan is at 5%. Another loan at... Where'd it go? 6%. And this kind of problem sometimes is silly. Like the person that puts money into a bank account and they put one at 5% and one at 6%. And they're like, dude, why didn't you just put the whole damn thing at 6%? What the hell's wrong? But this kind of makes sense because sometimes you can only borrow up to a certain amount. So then another loan, maybe 6% interest rate, but you need to borrow more money. So it kind of makes sense. If you go far enough in college, you'll start to realize that happens a lot. And it says the 5% loan is $1,000 more than the 6% loan. The total interest for 1 year is $215. $215. Total interest, $215. All right. So what are my variables going to represent? Or how many variables do I really need here? Which one is going to be just X? What am I dealing with here? I try to rewrite the problem a little bit, but now I've got to go back and say, okay, what's the English here? What am I... Well, 2. There are 2 parts to this. What are they?
The 6%.
Yeah.
X.
So there's a 5%, there's a 6%. And why would the 6% be X?
5% has 1,000 more.
1,000 more than that. So I got to know what this is first. So you see, that one depends on that one. So I got to call that. I love it. So this one I'll call X. And the amount at 5% would be what?
X plus 1,000.
X plus 1,000. Big ass. At least he was able to take more money at the lower interest rate. That makes sense. Good. That's the first step in this problem, of course, is write the English, translate it to the Mathish. Right? So how much interest did he pay on the 6% loan? How much money did he take out at 6%? How much money did he take out? Well, you know, we wrote it. X, exactly. X bucks, right? So he took X dollars out. So how much interest would he have paid?
200.
No, that's the total interest. What does that mean? Why is it called the total interest? Because that's the interest he paid on both freaking accounts. So if I knew the interest on one and I knew the interest on the other one, what would I do to get 215? Add them together, right? So I'm trying to figure out, well, what is the interest he paid on the 6% account? Well, it tells you it's 6% account. 6% of what?
Of X.
Of X. So if you take out a $2,000 loan at 5% per year, how much interest do you pay in a year? How do you figure that out? You take 5% of 1,000, right? Now in the real world, we know how much money we took out, right? This one, we're detectives. We're trying to piece clues together, so it's harder. But if you go back to example 12, it's exactly the same kind of problem. So if I take out this much money at 6%, how much interest did I pay? What is 6% as a number?
6 over 1.
So 0.06.
Yeah.
Is that cool? All right. 0.06 times?
1,000.
No.
X.
X. How much money did I take out at 6%?
X.
X. That's why you write this down, so you know what the hell you're dealing with. How much money did I take out at 5%?
X
X was 1,000. So how much interest did I pay on the 5% account?
X plus
0.05, 5% of
X
X plus 1,000. Yeah. You guys know this. Please tell me you know how interest works. If it's a 5% account, it's 5% of whatever the amount was, right? So 6% of X, bam. 5% of this, bam. And how do you get to 215? Add those together, because this is the interest he paid just on that one account. This is the interest he paid on the other account. If you add them together, you get his total interest. The word total is a giveaway. But example 12, again, they tell you, look at example 12. It's exactly the same problem, just different numbers. Right? So that's why the examples are so beautiful. So I'm going to let you finish that up. Unless the question, did you get that far, whoever asked the question? Okay, so you can take it from there? Good, all right. Yes, sir?
The same section, number 33.
Oh, all right, I like it. So everybody got what they want from this problem here? More than you wanted? Okay. All right. So, let's see. Number 33, same section, says, in 2005, the number of federal hazardous waste sites in California was less than twice the number of sites in Washington. How many hazardous waste sites were there in blah, 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 blah. So, first step. What's my first step? You don't have to draw California. So drawing doesn't make it. It's not a geometry problem. So what's my first step? Yeah, what are the players here? Yeah, the number of sites in California and the number of sites in Washington. The ka and the wa. Right, so again, the people that skip that step are the people that will make the simple mistakes. You just will. You just will. And let the first part of a word problem be easy. It's just English. Just write down the stuff you see. Is it Fred and Bob? Right? Is it gazelle speed and hawk speed? Write that down. I mean, whatever the English is that's involved in the problem, you write it down. And now you want to translate that to math so you can do shit with it. I can't do shit with number of sites in California plus. No, I got to set up an equation with math. So which one of these is going to be just X? Just rolling me around like you. The number of federal waste sites in California was 2 less than twice the number in Washington. Washington's got to be X. Because now what's 2 less than twice this? What's twice this?
2x.
And what's 2 less than that? That's 2 less than twice this. So the people that don't do this are going to set their equation up like this. You only have one state. You're missing the other state. Now it says, how many hazardous waste sites were there in Washington? Oh, this is kind of I remember this problem now. How many hazardous waste sites were there in Washington if there were 24 sites in California? So here you can make a mistake and still get away with it in this problem. So they tell me directly there were 24 sites in California. So what equation can I set up? Yeah, there were 24 sites in California. So in this case, you can just do this. Because they don't say the sum of the sites in both states. They say that there were 24 in California. So this must equal 24. So that word problem's a little bit evil, because normally you don't get direct information like that, right? They say, oh, they add up to be 28 or something. I guess, so that one's a little bit weird, because it was easier than we're used to. Okay, some of you guys are like, I don't think you know what that word means, so easier. But it's true. So you can solve that, right? Okay. Yes?
I have a question on chapter 1 for number 153.
Oh yeah, okay.
149.
149? 149?
Yeah.
Okay.
Well, I did it wrong because,
Yeah, I got you. We can do it. You can ask any question out of there. So nobody say we didn't get it assigned. It's fine. But real quick, yeah.
I did 2 minus 2x is equal to 24
Oh, so the mistake you made was if I said I had, let's say you got 10 eggs, and I got 2 less eggs than you. Do I have 2 minus 10 eggs? Do I have negative 8 eggs? No. What's 2 less than 10? 10 minus 2, right? So what's 2 less than something? That thing minus 2. So you wrote this backwards. 2 less than twice this is 2x minus 2. You got to turn it around. 2 less than 10 is 10 minus 2. You got to turn it around. That's English grammar screwing us up, not math. Math is like shit.
The problem is when I checked my solution is correct. So 2, I did n instead of x. So it's equal to minus
But your
1.
solution can't be correct. No, you mean when you plugged it back in, it worked?
Yes.
Because your equation was wrong. This is the unfortunate thing. If you don't have the equation, if you make your own equation and your equation is wrong, and the answer works in the equation, it doesn't mean it's the right answer because you started with your equation was wrong. Why does that answer make no sense? What does it represent physically? The number of waste sites. How could we have negative 11 waste sites, right? It's telling you something went wrong. Do you see that? So if you tell me that how much money or how many chairs do you need for the people and you get negative 50, what the hell is a negative chair? And how do I get 50 of them? I'm not making fun of you. I'm just saying in general for everybody. If it's a word problem, you should be able at the end, does it make physical sense? Math actually has to make physical sense. Right? All right. I like it. Cool. All right. Anything else from homework? I'm sorry. I was working on. Oh yeah, a couple people did this problem, and this problem is a little bit evil. If I said 1/5 of the population is over age 65, and 1/20 of the population is over age 85. This is the prediction for the year 2050. We're all going to get older and older and older because we're all going to live longer, which is not necessarily a good thing, right? This is number 149. So if you didn't do this problem, good. That's good because I didn't assign it, but you can ask questions on anything you want to. So, chapter 1, page 86. Chapter 1 review. So this is what they tell me. I'm just taking the important information out of it. How many people, what fraction will be between 65 and 85? I love this question. If 1/5 are over age 65 and 1/20 are over age 85, what fraction is between 65 and 85? And that's a weird ass question, right? You're like, what do I do with those numbers? So what I saw mostly on the people that did this problem is they multiply them together, which is not right. If you draw yourself a picture, it'll make it easier. Watch. Here's 65. So over 65, there's 1/5, right? Here's 85. Over 85, there's 1/20. So what do you do to figure out how many there are here? 1/5 is too much, right? You don't find the average? Well, now watch. What if I told you, let me use numbers. Let's say that there were 80 people over 65 and there were 20 people over 85. How many people were there in here? How many people were in here? Come on, you can do it. If there's 80 over 65 and there's 20 over 85, how many must be in there? 60. Do you guys see that? Of course there's got to be 60. Come on, you can do it. If there are 80 people above this and there are 20 people above this, how many must be here? Well, 80 minus 20. That makes physical sense, right? So what did I just do? I made easier numbers than what they gave me. I made the numbers easier and my brain went, oh, I see what to do now. So what do you do here? How do you get to what's left in here? 1/5 minus 1/20. So if you subtract 1/20 off, you'll be left with this chunk, which is the question. 1/5 minus 1/20. Hell no. I'm sorry, but I gotta be blunt. You should know what to do here. You need what? LCD. I'm sorry about that. I don't mean to. But I got to be a little hardy because I got to get you ready for the next level. This kind of stuff you should be able to. You shouldn't be making mistakes. But yeah, okay. That one was weird to set up. I agree. I agree. Which is part of the reason why I didn't assign it, because it was a little weird. All right, just in case you wanted to know, that's how you do that one. Anything else from homework? All right, so we're going to come back to 2.4. I'm going to do a little bit of stuff out of the lecture book, lecture notes. Oh, before I forget, did anybody come in? Let's see, Annalise, where were you? You were here, right? 4 hours? Did you get that back from me? Help me out here. I needed that back here. Vivian. Atra? Yeah. Where are you? Yes. Oh, there you go. Okay. What's up?
The absolute volume pissed me off.
Oh, yeah. Good. Get pissed off. It's the right reaction. I like that. Anger is a more useful emotion. Okay, so this is going to be page 16 in the lecture notes. If you don't have them, I'm going to put them up here. Oh, look at everybody. All right, so. This is section 2.4. We just barely got into section 2.4 last time.
Section 2.4, page 16.
Yes.
But I have another section. It's 2.5. page-
Which color is your cover?
Blue.
All right, so you got the old one. So find the page that has this on it. I don't know what else to tell you. Find section 2.4.
Who
That's
has
all.
the blue one?
Find section 2.4.
No.
That's 2.5. There you go. There you go. See? All right.
Yes.
What's up?
No, it's still there.
All right. So real quick, I want to point something out. They give you all these formulas up here that you might need in this section, right? But also in your book, whenever you get a math book, what do you guys check first?
Everything.
I check, when I was a student, I checked what answers does it give me? Not a bad idea. And I also check what the hell's in the front and back cover. So in the back cover of this book,
All the
there's
formulas.
areas and Pythagorean theorem, and there's functions, and there's interval notation, and all kinds of stuff, right? So it's good to know that. Oh, do you guys? What's the? Let me show you something kind of cool. What's the formula for circles? What's the formula for circumference of a circle? Do you guys know? Pi's involved.
Pi r squared,
That's not the circumference. That's the
diameter,
area.
2 pi r.
2 pi r. I like it. And real quick, I don't know if you guys know this, but however small or big cut the earth in half, that would not quite be a circle. Let's pretend like a circle. That'd be a pretty damn big circle, right? Cut Jupiter in half. Hello, big ass circle, right? No matter how big a circle you make or how small, when you divide the diameter into the circumference, so you measure this and you measure this, and this freaks entire civilizations out. Of course, right? Can you imagine not knowing a lot of math and like you do this, and you're like, why does it keep coming out to the same number? It kept coming out to about that number there. That's where pi came from. I don't know if you guys know that. Of course we're going to give it a letter. It's freaky as shit. Right? Any circle you imagine, you take the circumference and you divide by the diameter, it always came out to the same number. Of course they gave it a symbol. They're like, oh my God, this is some kind of... They of course thought it was from God and stuff like that. So different civilizations had different estimates for this. And now we have computers that spit out millions of... And we have people that memorize... I don't have any room in my brain left. So that's where the formula comes from. And what's the diameter related to the radius? Half. So that's why This is also known as 2 pi r. Let me stop there for a second. Everything I'm about to show you is nothing you have to do on your own. I just want to show it to you. Because some of you guys know the area formula, obviously. You know it's pi r squared, right? Yeah, no, pi r not square. Pi r round. Now this is really cool. I don't know. Let me see if you guys go with me on this. This is just kicks so much ass. Alright, so if I want to figure out the area, for example, if I wanted to know the total area of this, couldn't I do the area of the square and then the area of the triangle and add them together?
Yes.
Of course I would, because I don't have the area of a house shape formula sitting around. I just break it up into areas that I know. So just go with me on this. You never have to do this on your own. I just want to show this to you once at least in your life. So if I had a circle and I cut it in half, and then I cut out to the edges. So how long is each of these?
They're same, half of
So how long are they?
Radius length?
Radius length, look at that, kick-ass. They're all r long, right? They're all the radius, right? They all go from the center out. But I don't cut through the edge, so I can open it up like this. Can you guys see that in your head? I can open it up like that. So if I pick that up and open it, it would look like this. Is that cool? Do you guys see that? And some of you guys have turned out because you said I didn't have to worry about this shit, so I'm not going to watch. Whatever, I don't care. Do the same thing. Now, real quick, before I go too far. This is like R about, right? You with me?
Yeah.
And how long is this? I don't know, Jeff, shit. But how long is it all the way around? It's this, right?
Yeah.
And where did this come from? Isn't this here? When I open it up, that's where it came from, right? So what's halfway around then? If all the way around is 2 pi r, halfway around is
over
pi r. So this is pi r. It's weird. I love it. Stay with me. You guys kind of with me here? So watch. Do the same thing with the bottom half and fit it in. Pop. What shape did I make? Rectangle. And what's the area of the rectangle? Pi r times r, which is pi r frickin' squared. Holy shit. All right. I like that. That's where the formula comes from. That's one place you can show where it comes from. It actually came from calculus, but now we're like, we don't need all the calculus shit. We can do it right now. All right, so you guys semi with me? Again, all that was just me showing you cool shit. You don't have to know where it came from. You just have to know how to use it. All right. Enough of that. Let's see. What was the other thing? Oh, well, nah, I'm not going to do that too. I'll overload you with stuff. That's your job, Jeff. So let's look at some of these here. Cooperate. There you go. So for example, there's your area of a circle. Area of a triangle, we talked about that a little bit. Triangle's like half of a rectangle, so that's why it's got a half base inside. I don't know if surface area of box is going to come in, who cares? We know the first two. Trapezoid. Doesn't that look like the area of a triangle? Just it's got two bases. Because a trapezoid looks like a triangle that's been beheaded, right? So it's got two bases. So that's why that formula looks almost the same. It's 1/2 the height times the sum of the bases. So that's what a trapezoid is. All right, maybe. Anyway, volumes and stuff. Okay. So let's see what this stuff looks like. Some of them are very, very, very simple. Like the first one. Right? What's the area of a rectangle with 6-inch width and a 10-inch length?
6 by 10.
That's the dimensions. What's the area?
6 plus 10 by 2.
Area, not perimeter.
60
60 what?
inches.
There you go. Inches squared. Why is it inches squared? Because what's 6 inches times 10 inches would be 60 inches squared. It's inch times inch is inch freaking squared, right?
I told you 6 by 10.
So don't tell me the problem to solve.
Okay,
tell me the answer.
I'm sorry.
All right? It's not my job to do the work. It's my job to grade your work. That's easy, right? That's easy. So they're going to tell you in words what you could get as a picture, but you got to draw your own picture if you want to. Circumference of a circle with a 4-inch diameter. So if the diameter is 4 inches, What's the formula for the circumference?
2 pi r squared.
2 pi r, or even better, pi d. Because what's twice the radius? The diameter. So circumference is pi d, and what's the diameter?
3, 14, 16.
Who to what? What's the diameter?
4.
4. So it's 4 pi what?
That's it.
4 pi what's?
Isn't it just that?
4 pi what's? Units.
Inches?
Inches, thank you. Well, it's not area, it's length, so it won't be squared. You guys understanding what's going on here? There's a lot of formulas that you can look up. They're in there, they're in the book, and you just got to plug the numbers they give you in. Oh my God, let that be nice. The units, you just got to know how to work with units. You have to. And if you don't give me units, you might lose points if you do enough without units. Is pi equal to 3.14?
No.
Thank you, God. Thank you. It's not the same. It's an approximation. You should have, hopefully, maybe, some of you guys have a calculator with a pi button in it, right? Maybe. Then you don't have to approximate. So if you did do 4 times pi, does anybody have a pi button, know how to use it? What's 4 times pi?
12.56. 57 if you round it up. It's
12.57 roughly? Yeah, 12.56, because 3.14 is a good approximation. I like it. 12.57 inches. So both of those are acceptable answers. This one's exactly right, and this one's an approximation.
Okay, that's what I was going to ask you. I was like, do you want us to actually solve it? Like the...
I'll be specific on a test or something, and I can't remember if they say... Well, they give answers both ways.
Okay.
So yeah, you can give it to me like that and say it's equal to that.
Okay. So as you said, to just go ahead and use the pi button and type it in 3.14.
Yes, totally. And I really want you to understand, if you use 3.14, your answers will always be smaller than it's supposed to be, because you've cut part of pi out. So if I multiply 3.14 times a million, I'm going to be way far off from what the right answer is. Do you understand? Maybe? Maybe? All right. What about number 3?
It's A equals 1/2.
Oh, wait. All right, so A is 1/2 BH, and now you just got to plug this stuff in the right place, right? Mm-hmm. Make sure your units are the same. So A equals 1/2 what?
10 by 14.
10 by 14, I like it. Yeah, 1/2 of 14 is 7 times 10 is 70 what's?
Centimeter. Square.
Square. I like it. So area, how do you cover a floor? What shape is the easiest way to cover a floor? A little square will cover floors, right? How do you fill a room? Cubes, right? If you ever moved anywhere, you Tetris the boxes into the moving truck, right?
Right.
And if they're all the same size, but U-Haul always says, oh, it'll work, and you're like, never. Never. But anyway, you guys kind of with me? That's why volume will always be cubic, because there's 3 dimensions to volume, right? Area, there's 2 dimensions, this way and that way.
Square.
Volume, there's 3 dimensions, so the answer is going to be cubes. Cubic, right? Cubic inches, cubic whatever. Maybe. Yes, sir?
Just do base times height, rather.
Totally, yeah, same thing. I love it. So 10 times 14 is 140, divided by 2. You're just rearranging the how you're doing things. You're fine.
Just to avoid using a fraction.
I'm with you. That's fine. All right. Oh, so here's the problem like I talked about just a minute ago. See if you guys can do number 4.
$135 feet square.
You don't know if it's right. But yeah, in general, just wait. Let everybody have a chance. But we don't know if it's right yet. Check it out. What have you been doing? So make sure everybody's on the right track. How many shapes are there? 3. There's a little triangle. There's a big triangle, and there's a rectangle in the middle, right? So it's like 3 area problems. So to get the whole area, you just add those areas together. Good. So I'll call this A1, A2, A3. So how do you get area 1? This little triangle over here. Yeah, 1/2. What's the base?
2.
And the height? 5. So 1/2 of 10, or 10 divided by 2? 5 square feet so far, right? What's the area of this rectangle?
100.
Good. It's 20 times 5, so it's 100 square feet. You guys kind of with me still?
Yep. Yes.